Hi, and welcome to this course on data literacy. My name is Jess, and I'll be one of your instructors for this course. Why learn about data literacy? Just as we had to adjust to using computers and to using the internet, we now live in a time where data is all around us. As a consequence, to keep up with the changing world, it is important to know data, know how to interact with it, know what it can do and what it cannot do. Data is all around us. We can learn about the world through data. However, we are confronted with lots of information, often with a high degree of complexity. How do we turn this into valuable insights? Being data literate means we understand how data can be combined and connected to create value. Data literacy is not about technical skill, like coding or understanding the maths behind a data analysis. Instead, it is about learning how to critically think about and interact with data and its analysis by understanding its relevance, placing it into context, and knowing both its potential and its limits. Compare this with learning how to drive a car. It is not necessary to know all the bits and pieces under the hood or how to repair it, but you do need to know the difference between the brakes and the gas, know how to follow instructions of traffic signs, and that you can't drive in water. Data literacy can be defined as follows. It is the ability to read, work with, analyse, and communicate insights with data. We can distinguish three main components here: reading data, working with and analysing data, and communicating insights with data. Reading data consists of identifying relevant data sources, collecting the data, and managing the data we have collected or already have available. You might already have heard of databases. Databases help you to store, organise, and share your data. You'll learn more about this in Chapter 2. Working with and analysing data is how we turn data into insights. Our main tool here is data analytics. For example, descriptive or predictive analytics. Don't worry if these terms don't mean anything to you yet. You'll learn more about them in Chapter 3. Finally, no insight is valuable if we don't know what to do with it. This is the main purpose of communicating insights with data, demonstrating our insights and their value, and even more important, defining a possible set of actions we can take based on the insights we gained. The main tools used for communicating are visualizations and storytelling, which is the use of techniques and structure from stories to enhance your communication. You'll learn more about this in Chapter 4. Now that you know more about data literacy and why it is important, let's practice. One of the main reasons why data is so important is the added value of turning data into insights. But what does this mean exactly? And why is it important? That is the topic of this video. To better understand the value of data, we can use the data, information, knowledge, and wisdom framework. Each step of this pyramid represents a new step we can take. The higher we go, the more value we can get from data, starting from raw data all the way up to perfect wisdom. In the following slides, we'll break down each step. Raw data consists of loose observations or measurements. It does not have meaning yet. It is unorganised and unprocessed. For example, we can measure with a thermometer that is 15 degrees Celsius, observe that there are dark clouds, and that some raindrops are falling. Right now, we don't know what these separate facts mean yet, or how they connect with each other. Information consists of raw data placed into context. This is typically done by organising or aggregating data. In the weather example, we can organise our raw data by putting it in order. First, the temperature dropped, and then it became cloudy, and then the raindrops fell. In the knowledge step, we combine information to make connections, learn, and gain meaning. This is typically done by detecting patterns, making generalizations or predictions. In the weather example, we can surmise the possible causal connection between temperature, clouds, and raindrops, and use this to predict whether or not it is going to rain. Wisdom is applied knowledge or knowledge in action, as it allows us to act proactively. This is typically done by combining knowledge logically to determine the course of action. To come back to our weather example, with my accumulated knowledge, I know when it is going to rain and so also know when to bring my umbrella. Getting from data to wisdom involves several steps. In each step, we add something new. Going from data to information, context is added. Going from information to knowledge, meaning is added. However, the step from knowledge to wisdom is a big leap. The concept of wisdom implies a sort of perfect, complete knowledge, which in reality we can maybe approach but not quite reach. In the weather example, if we look at temperature and clouds, is that enough to perfectly predict rain? Can we truly know all the factors that come into play and measure them? And what if we want to predict rain tomorrow or next week? To solve this problem, we need a go-between, and this is where insights come into play. It can be considered a gold nugget, a kind of manifestation of wisdom that we can realistically achieve. And as we keep gathering insights, we can get one step closer to that perfect wisdom. For example, knowing about the effect of temperature and the formation of clouds might be enough to be reasonably certain a few hours beforehand about the possibility of rain and the need to bring an umbrella. Adding in the insight that humidity is a better predictor than temperature, we can improve the accuracy of our predictions. Next, using insights on atmospheric pressure areas, we can start predicting rain a few days ahead and keep that umbrella close. Eventually, we might get enough pieces of the puzzle to start seeing the full picture. Now that you know how to walk the path from data to insights, it is time to put your knowledge into practice. Previously, we talked about why getting from data to insights is valuable. Now we will discuss how to get the most value out of data through data-driven decision-making. Data-driven decision-making can be defined as follows. It is the process of using data to make an informed decision about a specific problem and acting upon it. It can be used for optimizing performance, gaining a better understanding, protecting against risks, or determining the best course of action. The importance of data-driven decision-making is a topic of many articles, with headlines such as these. Unfortunately, this has also led to some misconceptions. Data-driven decision-making is not just for large organizations. You can start small. It is not just the responsibility of the data team. In fact, by including people with different backgrounds, the data-driven process will be enriched. It is not the only or always the best option. Data-driven decision-making is a strategy with its own advantages and disadvantages. No matter what type of data-driven project you undertake, there are 5 main steps that underpin every data-driven process. The first, and very important step, is defining a problem statement, which will guide the rest of the process. The second step is to collect the necessary data. The third step is to perform data analysis. The last two steps are about communicating the results, and of course, taking action on our newly gained insights while reflecting back on the process. Effective data-driven decision-making is driven by a well-crafted problem statement. Because of its importance, we'll go over this in more detail. Simply put, the problem statement answers the question, what is the problem you want to solve? It acts as a guide to which data to collect, which analysis technique is appropriate, and how the results can be used. It can refer to an issue that needs to be addressed, impact that needs to be made, or a question that needs answering. Typical problem categories are as follows: describing the state of an organisation or process, diagnosing causes, detecting anomalies, or predicting events. There are 3 guiding questions that can be used to craft a problem statement. What is the current situation? What do we need to know? And where do we want to be? A good problem statement has the following characteristics: clearly defined, be specific, actionable, specific actions should be possible based on the eventual answer, and realistic, possible to solve with the available resources. It can also help to use a specific question to start from. For example, imagine you are part of a customer service team and need to advise management on customer satisfaction. The starting question could be, how can we improve customer satisfaction? From there, the problem statement can be defined as follows. Customer satisfaction is currently under our target. We need to know the main reasons for a negative score so we can take measures to improve customer satisfaction. For the next example, you're working for a university and are tasked with monitoring student performance. Your starting question could be, why are average maths scores of students in decline for the last 3 years? Starting from that, we can craft the following problem statement. The last 3 years' maths scores of students have declined. We need to know what the main causes are of this decline so that we can take measures to counter it. Over to you.